All right, guys, welcome to our last unit. This is it. Knock this one out, and we are done with math, and we're moving to Christmas break, and that sounds good. So let's dive in. This is our quadratics unit. It's going to take up about 2.5 weeks, something like that. We'll see how far we can get into quadratics, and let's dive in. Okay. Quadratics are a function. They're in the function family. So we're going to go back and talk about the first set of functions we've worked with, which are the linear functions. Okay. So if we look at this one on the left, this is what we call a parent function, meaning it's the simplest possible linear equation you can get. It's y equals x. And if we think about it in terms of slope and y-intercept, remember it's the y equals mx plus b is how we think of our linear equations. And so this one, in terms of the m for slope, there's just that invisible 1. It's got a slope of 1. It's just going up 1 over 1, up 1 over 1. It's the most simple basic slope. It's just a 45-degree angle. And then we've got our b, which is our y-intercept, and we can see it's crossing the y-axis and the x-axis both. It's crossing right at 0 because we could just think of it as plus 0 at the end if we needed to have an intercept showing. So that's the most simple function you can have for the linear family. It's just called a parent function. From here on out, all the other types of linear functions, you're just changing the slope, that value of 1, or you're changing that intercept, which starts as 0. And so now this becomes something probably pretty familiar to us. Y equals, we can look at it, something x plus something, and then we could just pull out the slope and the intercept, and so we'd look at it and say, well, it's pretty clear. -2 is where it crosses, so we could say plus -2 or just say -2. That's just as easy. There's our intercept, and then for finding a slope, we'd say, well, it goes up 1. It goes over 3, and so that's a 1/3. And there we've got a linear function. Okay, so this is all review. We've seen this stuff before, and this is the most basic function family of linears. And notice when we talk about a solution, there isn't a solution to these because there's an infinite number of points, so there can be all kinds of point solutions on here. We don't talk about it unless we go back to systems of equations, and if we drew a line, like if I went to this graph and drew a line right here, let's see how good I can do that. If I did that, and that green one was a second line, then I'd say, oh, the solution to the system is the point where both these lines cross. And that's really the only way you get a solution with systems of equations, is when you have two lines crossing, the point is the solution to both. Otherwise, that's really all there is to the entire linear function family. There's slope and intercept, and you make lines. So let's step to the new function family of quadratics. Okay? Quadratics, if we look at this left one, this is the parent function, meaning this is the simplest possible graph of a quadratic. And quadratics are this one feature, x squared. Okay? That's what makes quadratics. Quadratics is that the x isn't just a single power like it is with linear. It's squared, and anytime you graph, if you go to Desmos, that's where all these graphs are from I'm using today, or you were just going to use a t-chart and plug in some values, any number you take for x and square it, they're going to graph into this curving upward U shape, and that's going to be our quadratic function. Okay, so that's our basic parent function, and that's the shape. And we'll get into the details of this in just a minute. And just like, there we go, just like a line, there's arrows on here. That graph, and it's called a parabola. We're going to get to that in a minute. That parabola goes forever in both directions. Okay. Now the second one over here is just another parabola. It's also going forever in both directions. Okay, so we should be seeing arrows on these. And notice parabolas can go either way. They can go upward, they can go downward. They won't curve left or right. They will only curve up or down, but they can go up or down, and they can get wider or they can get skinnier. When it goes downward like this, it just means that x squared term on the front of the equation is negative. Anytime you see a negative on the front of the x squared, you know the parabola it would make, if you look at the graph, is going to go downward. Okay? And then there would be potentially some other stuff behind that one. Off the top of my head, I don't know what that graph would be, but it might be something like plus 4x minus 3. Now that is not what that graph says, but there's just an example quadratic, okay? It always has an x squared term, and then often it will have the x term and it will have the constant, and I hope that is starting to look familiar. That's the trinomial at the end of a FOIL problem, okay, which we've already learned how to factor. But that's generally what your quadratics look like. The simplest version is this parent function. It doesn't have anything but the x squared, and then everything else we add behind it. Notice our parabola is not centered at 0. It got shifted over this way a little bit. It got flipped downward, and then it got moved upward a bit after it got shifted. So all of this stuff moves your parabola around in various ways, okay? But any upward or downward curve like this parabola is a quadratic, and they all start from that parent function shape on the left there. All right, if we flip back to this page, right there is our vertex on that original parent function. And it's at 0 for the x and 0 for y. It's called the origin. It's right at 0. Looks like a little dude there. And that is the lowest point on that graph, okay? So if your parabola goes upward, your vertex is the lowest point. It's also something you should know. But if your graph is going downward, your vertex is at the highest point. It just depends on the direction of your parabola. And this one, if we look right in the center, it's in between 1 and 2. So you'd have to say 1.5 for the x value. And then it's in between 2 and 3. We would have to guess like 2 1/4. I won't be giving you fractional values like that, so you'll get whole numbers, don't worry. But that's the idea. That's your vertex. And then if we drew it, there's our line of symmetry right down the middle. Okay, features on a quadratic graph. So let's talk about the details of what's here, and this will be on the test. You'll have a place coming up the next couple weeks where the quiz will have this, and you'll be identifying each of the pieces on here. All right, first of all, notice that these guys always are symmetrical, meaning I could draw a line right down the middle of this. If I were to draw a dotted line right down the middle of this guy, it's exactly the same on both sides, okay? So let's talk about that real quick. Do you guys know what symmetrical means? It means that if you were to fold something in half along that symmetrical line, or that line of symmetry, it would match up and be exactly the same. For instance, a picture of your face. If we were to fold it side to side in half, top to bottom, folding it, your face will match. Your eyes, your nose, your ears, it's all symmetrical, okay? If you were to take something like a guitar lengthwise and fold that picture end to end, it's not the same end to end, but you could fold it top to bottom if you're thinking about how somebody has a guitar they wear when they're playing it, and that way it would be symmetrical. So the line that cuts it in half would divide things evenly, okay? So in this case, that's actually called the line of symmetry. It's just the line that cuts this parabola in half. It goes right down the middle, and it's literally that simple. Your parabola will always be something you can just draw a line right down the middle. And so our line of symmetry is at an x value of 3. So remember, this goes back to our lines. When we draw vertical special case lines, we ask ourselves, what does it cross, x or y axis? Well, it's crossing the x axis. Where is it crossing at? It's crossing at 3. So that vertical line is x equals 3. So our line of symmetry is at x equals 3. Okay. So you just look at where your graph, where your parabola gets split in half, and that's called your axis of symmetry. And then right there at 3 would be how you would write that out. All right, next. Probably the most important thing you want to be able to read off this graph is the solutions. And notice this is different from our linear functions. Linear functions don't have a solution unless you have 2 of them crossing in a system. These, a quadratic equation, a single quadratic equation, do have solutions. And the solutions are right here. Okay? And remember, that's where that parabola, that graph, is crossing the x-axis. So what do we call that? What do we call the point where any graph crosses the x-axis? Do you guys remember? Called the x-intercepts. And the x-intercepts are the solutions to this quadratic equation. That's important. So later on, we'll learn to solve these with the algebra, with our equation work, and there won't be a graph. And when you find your solutions, if you graphed the equation as a graph, that's where it's going to cross, is at those 2 numbers you find. So for this problem, this quadratic, we've got solutions for x equals 1 and x equals 5. There's our 2 solutions. So literally, I would give you a parabola like this and say, what are the solutions? You just need to read the x-intercepts. Those are your solutions. Now notice, somebody might wonder, what about the y-intercept? It's down here somewhere. We can't see where it's going to cross. Somewhere it's going to cross down there. Turns out, y-intercepts are not important to parabolas. When you're dealing with quadratic equations and you're graphing their parabolas, y-intercepts aren't important. They're not any specific piece of information that you regularly use, so don't worry about y-intercepts. Just remember your x-intercepts. Those are your solutions. Okay. All right, and then the name, don't forget, the name of this is called a parabola. Okay, these guys are called parabolas. They have solutions at the x-axis, and the line right down the middle that cuts them in half would be called your line of symmetry. One more thing. I know, you might feel like it's a lot, but this is it. Once we have this one, we've got all of them. Right where your line of symmetry crosses your graph, there's that one point right in the center where it'll always cross the middle of your parabola. That guy also has a name. And the name is the vertex. And it's a point, just like any other point on a graph, on a line, anything you're working with. It's a single point. And so what is that point? Well, it's got an x value of 3. Remember, we read the x value first of points. A lot of you guys have been struggling with that. When we're doing systems of equations, you're flipping your x and y values. Remember that all points have x first, y second. So x value of 3, and then the y value, if you count upward, y value of 4. It's right there. Okay, so the vertex of this parabola is at 3, 4. It's the point right there where your line of symmetry crosses. So in this case, the vertex is the highest point of this graph because it's going downward. Okay, probably use some more help. Why don't we do this one as a we do, okay? I'll give you a minute. You may be just fine and be able to knock all of these out yourself, but we need to label each of these things. Now, you can't draw on this because you're just watching the video, but the vertex is a point. So what is your vertex? The x-intercepts are x equals. Okay, you can just tell me the values on the x-axis that the x-intercepts are. Solutions, you can just tell me what the solutions are. And the name, you can just write out. So really, it's just the axis of symmetry. And remember, that's a line. So write the equation of the line. Okay. So actually, you can write all these out. I was wrong. Without needing the graph. So take a minute, see what you can do, and then we'll walk through it together in a minute. pause the video if you need some time. All right, let's see if we can, whichever ones you got, I'll help you with the rest. The vertex. Remember, the vertex is that highest or lowest point. It's right in the middle. So I'm going to start by drawing this line. Do you guys remember what that's called? That's my axis of symmetry. And the vertex is going to be, I'll try to keep my colors changed up here. The vertex is right on that axis of symmetry. Those two go together. So there's my vertex. And so I'm just going to count. It's got an x value of -4, y value also of -4. That's a bummer because now we can't tell if you got the order correct, but hopefully you put your x value first. Okay? That's my vertex. And then my line of symmetry, remember, it's just an equation, and it's where the line crosses what? Crosses the x-axis. Where does it cross it? Crosses at -4. And by the way, the axis of symmetry is always going to be vertical because the parabolas are always vertical. So that's always going to be how the axis of symmetry looks. It's always going to be x equals, and then that's the line of symmetry. Okay, so x-intercepts. It's just where my parabola crosses, and it crosses at -5 and at -3. So my x-intercepts, -5 and -3. Solutions. Did you find the solutions? And yes, hopefully, I was just seeing if you were paying attention, these are exactly the same. Our x-intercepts are the solutions, always. So we already know the solutions. They're -5 and -3. There's the solutions to this parabola. And what is it called? Well, I've said it about 6 times now. It's called a parabola. Okay? Hopefully this is starting to connect some dots for you guys. You're getting the basics of this. And remember, a quadratic is the family of equations that start with x squared. Okay? X squared, like this. When you graph them, the graph of a quadratic is called a parabola. Okay? To keep those straight. We have quadratic equations, and they graph as parabolas. All right. Number of solutions. If the solutions to the quadratic are when it crosses the x-axis, then it's pretty easy on this first one. Solutions, which are just our x-intercepts. And what are they? They're right there. I don't know if that's easy enough for you guys to read, but those say -3 and -5. That's the one we just saw a minute ago. So the solutions are always for what x equals. So it's x equals -5 and x equals -3. What about this one? That probably looks a little different. It's not double crossing with both arms over the x-axis. So what is our solution here? It's this guy. And notice, if our parabola can be moved around, which it can be shifted left, right, and it can be shifted up, down, there might only be one solution sometimes, and in this case, it's just -4. Okay, that can happen. We can have kind of a traditional, which is what we see most of the time, 2 solutions, because your graph crosses the x-axis twice with both arms. Or you can have one solution because that parabola has been raised up in just that very bottom tip. And by the way, what do we call that? Our solution in this case is right in the same position as what? What else do we call that point right at the center of our parabola? In this case, our solution is the vertex. Hopefully you're seeing that's the same thing. The vertex is at -4, 0. So notice on this one, they're exactly the same. Solution of x equals -4, and it's the point That's the center of your parabola, so it happens to also be your vertex. Okay. Vertex is a point, we write it as. Solution, or the x-intercept, you just tell us x equals. We just want to know what the value for x is at your solutions. All right, last. What the heck do we do with this one? What's our solution here? Well, it doesn't cross anywhere. Nowhere on our x-axis does the parabola cross. That means there is no solution. That's also totally valid and possible with a parabola. We've got a graph parabola. It is a quadratic. Everything's as it should be, but it's been raised up above the x-axis far enough that there are no x-intercepts. So if there's no x-intercepts, there's no solution. So notice, you guys would be given various graphs, and it might be one where you've got two solutions, it might be one where you've got one, or it might be a no solution. You just have to read the graph and see. All right, let's get to your homework. Practice problems as well for this session. There's 3 pages. Notice it says page 1 up there at the top. There are 3 pages, and they're all just the same thing. I give you a graph, and then you've got this set of things that you need to label about that graph. What is its vertex? What is its x-intercepts, the axis of symmetry, the solution, and the name? I will go ahead and solve all 3 of these behind you. So if you are struggling, or I would recommend making sure you're doing it right, pause it, do page 1, unpause it, I'll work through it. Pause it again when I get to page 2, work through that one, then check the solutions with me. And then do the same on page 3. And hopefully by the 3rd one, you've got everything dialed and you've got an understanding, okay? All right, pause it now, work through this first one, and I'll go behind you and we'll start solving. Go. All right, let's just go down the list and knock it out. Vertex. Remember, vertex is a point on the graph, so I want to write down a point. And it's right in the center. If I'm looking at this guy, it looks like the center is right here. Now I'm drawing the axis of symmetry, but that just gives me the place to put my vertex. So there's my vertex, and what point is it at? It's at an x value of 3, y value of 4. So that's the center of the graph, and also the point that's the highest or lowest point on this graph. In this case, it's the highest point. I didn't ask you to name that, but it's good for you to understand. That vertex would be the highest point on that parabola, and it goes downward forever from here. All right, our x-intercepts. I'm actually going to skip for a sec to do the axis of symmetry, because that just goes with the vertex. My axis of symmetry is that line I just drew right down the middle, and where is it located? On the x-axis. It will always be on the x-axis, and it'll be at 3. So the axis of symmetry is the line at x equals 3. Another thing to notice, the vertex x value is always going to be the same as your axis of symmetry, because they're both the middle of that graph with their x value. All right. X-intercepts, where is this crossing the x-axis? Right there and right there. So our x-intercepts are at x values of -1 and 7. And now if I jump to the solution, did I still get you again? Hopefully not. Solutions are the x-intercepts. They're the same thing. And what is the name of this graph? It is called a parabola. Okay? It's called a parabola. All right, there's your second one. Pause it and do it again. Go. All right, I'm going to go right behind you. I'm going to start with the center line on this, which is the axis of symmetry. Okay, there it is. It's right at 4, so it's at an x value of 4. From that, it's pretty easy to grab the vertex. The vertex is right there. And that point for the vertex is at x value 4 and a y value of 0. Okay, so there's my vertex. And in this case, it is the lowest point on this graph because the graph goes upwards for forever from here. Starts at 0 on the y, just goes up to infinity on y. All right, my x-intercepts. There's only one of them. The only place that graph touches the x-axis is right there. Wow, all the action is right at x equals 4 on this graph. Everything keeps coming back to that. The one x-intercept is at x equals 4, and I bet you're getting it by now. That's also the solution. So this is an example of a one-solution quadratic equation. His parabola only touches the x-axis at that one point. And what is this called? I bet you know. It's a parabola. Okay, there's number 2. And there's number 3. Go ahead and pause that one. And again, very broad, very open, but still a parabola. It's just been really opened up wide, but it's still that arc shape pointing upward or downward, so it is a parabola. Pause it and fill in your info. All right, going right behind you, looking at it, the vertex. And if you have a hard time trying to figure out exactly where the center is, here's a little help for you. I would just look right here. Notice it's going to go upward until it peaks, and it's continuing to go upward until it gets right into this zone here, and that's kind of the high point. So that kind of tells us it's right at -6. That's where we're going here for our vertex. Or excuse me, not our vertex, our axis of symmetry. And so it's at the x value of -6 is my axis of symmetry. Vertex is going to be right here, which is at the point -6 for x. It's always going to match. Those guys are always going to match. And a y value of -1. So there's my vertex. Okay, now we've got our x-intercepts, which do not exist on this graph. There's our x-axis, and there is nowhere that our parabola touches it. It's going downward, and it's been drifted down below the entire x-axis. So there are none. There are no x-intercepts here. What does that tell us about solutions? It tells us there are no solutions to this quadratic. Okay, it can be graphed. It is an equation. It can be graphed as a parabola, but it has no real solutions. Okay, there's something called imaginary numbers. You'll get into that in Algebra 2. You can explore if there's imaginary solutions here, but there are no real solutions. So for us now in this course, we just say there's no solutions. And finally, boy, this has to be in your head by now. It's called a parabola. All right, that's it. I will see you in class hopefully tomorrow.